Calculate the mass of hydroxylamine required to dissolve in enough water to make 250 milliliters of solution having a pH of 10.0. And also we are given the Kb value. Okay, we have to find the mass of this weak base. So that's our goal. And we'll first write the dissociation of this weak base in water. So we have HO and H2. Since it's weak, we need this equilibrium sign, and then we need to break this apart. Now I'm gonna identify the ice chart, because ultimately when we are given the pH, we have to use the equilibrium concentration of the hydroxide ion, and from that we can find the change happening. And finally we have to find the concentration of the weak base at equilibrium, and from that we can find the mass. Alright, so here we go. So the starting point is the pH. We are given the pH equals 10.0. Now we want to find the pOH because we are given the Kb value, and in our reaction we have hydroxide ion. So pOH is basically 14 minus pH. We get 4.0. If you want to find the concentration, you just have to use 10 to the pOH on top. Now this goes into our ice chart, in which OH is located, and it has to be at equilibrium. So 1.0 times 10 to the negative 4th at this location. And initially we do know that the NH2 plus and OH minus was 0 molar, meaning it wasn't dissociated until the reaction took place. And from this you can deduce that there's a plus X and plus X, but that plus X is going to be simply this value. So we have 1.0 times 10 to the negative 4th, and the same thing. And due to the stoichiometry, we know there has to be negative X, and that's simply negative 1.0 times 10 to the negative 4th. And we do not know the initial concentration of this hydroxylamine. Therefore, I'm going to set this equal to, for now, Y. That means in our equilibrium concentration, we'll have Y minus 1.0 times 10 to the negative 4th. And over here, I'm simply going to have 1.0 times 10 to the negative 4th for the NH2 plus. Okay, so looking at this, we can now connect this information to our Kb. The Kb is equilibrium for this base reaction, so it's going to take the product. So it's going to be OH minus NH2 plus over our reactant. You plug it in, and the concentration of the amine and the hydroxyls are same, so you can simply square it, and then you have Y minus 1.0 times 10 to the negative 4th equal to the given information, 1.1 times 10 to the negative 8. And we just have to find the Y now, which is our initial concentration, okay? Because after you find the initial concentration, we get to find the mass we need to achieve this reaction, this experiment. So we're gonna okay, so you can cross multiply this, which I'm not gonna do here because that's something you should be able to do it in your free time, or at least you need to be aware of algebra 2 to solve this kind of problem. So yes, so y happened to be 0.9091 molar, okay? Or the worst case, is say your teacher allows you to use calculator, just plug it in, say y equals 1 here and y equals 2, and then find the intersection, and you don't really have to do cross multiplication if you don't want like that. So having said that, I found the initial concentration of our reactant, hydroxylamine, and from this, and also we are given the clue that 250 milliliter was used, okay, over here. We got the volume of solution. Okay, anytime you see the volume and the concentration, you know you can find the moles of this compound, and then once you find the moles of compound, you can also find the mass by simply looking at the periodic table and then convert it to mass. So I'll show you one by one, step by step. So I'm gonna start with the volume, given volume. It was a 0.2500 liter. Technically it was milliliter, but I just converted it to liter by moving the decimal point times. So this step is finding the mass. Okay, so that's the reactant, in case you're still wondering what that is. We're gonna use this molarity, and all I'm gonna do is split them apart. So 0.9091 mole per liter of this same reactant. And now I want to find the mass of the hydroxylamine. Okay, if you look at periodic table, you're gonna get 33.034, and then here you have to have 1 mole of the compound. Now let's cancel out anything that's not needed. And you will get 7.507 grams of, in other words, you need this much to achieve this effect. But we need to be also aware of the sigfig. Okay, the pH had the 2 decimal, so that becomes our sigfig, 2 sigfig, and throughout 2 sigfig is the lowest we can have. Therefore, you have to make this to 7.5 gram of this hydroxylamine. So let me rephrase what I did from the beginning. So step 1 was to find the pOH. And then find the concentration of hydroxide. And then step 2 was to devise the ice chart. And then step 3 is to find the KB, set up the KB, and then find the initial concentration. Of hydroxylamine. And then step 4 is just simply find the mass.